Hello, everybody. Thank you all for virtually showing up to my talks, C# and .NET for object-oriented programmers. My name is Jort Rodenburg, and I am currently a software engineer with Workiva in Phoenix, Arizona. I was rather looking forward to going to Manchester. I've never been, but the circumstances kind of dictate we're virtual for today. So first off, if you do hear a fan in my background, I apologize. I am in my apartment in Phoenix, and outside it's about 35 degrees Celsius. This is gonna go a lot smoother if I have some airflow. So what am I gonna talk to you about today? Well, this talk is going to give you a brief overview of what C# and .NET are, why you should use them, some places to start, object-oriented concepts, and after that, I'll give you some neat pro tips to use with C#. I'll be presenting for about 35, 40 minutes, and I'm sure we can handle any questions that come up afterwards. So like I said, the main strokes and topics are what C# and .NET are, some object-oriented programming in C# and some pro tips. Now at this point, I'm going to have to do the obligatory promotional slides from my book. I am the author of Code Like a Pro in C#, which is published through many publications. The book is currently estimated to be physically released either by the end of this year or very early next year. It's kind of up in the air still. When I was preparing my talk, I was going to say that you can now read the first 8 chapters of this book online through Manning's Early Access program. However, about 30 minutes ago, I did get an email saying that all the chapters are online now. So there's that. There is also a 20% off coupon on the screen in case you're interested. And parts of this talk are based around the content in the book, but there is plenty more in case you're interested. The book is a walkthrough of a total refactor of a web service, and you'll find weird things like Socratic dialogue, history lessons about Frisians, and some general things in the book. So to be my publisher, if that sounds good, please buy a copy or 10, buy some for your friends and neighbors. They make great holiday presents. And then there is also a raffle. I do have 3 free ebook copies to give out to attendees. So if you would like to enter that, go ahead and go to jortrodenburg.com/raffle and be sure to enter before Sunday. I will contact the winner on Monday. So that's great, but why should you care to even listen to me? And in particular, because I'm going to be talking about a language that has been here for about 20 years now. And I hate to pull the I wrote a book card. Yes, I wrote a book, but you don't know how good the book is. So you're kind of stuck with me for the next 40 minutes or so. You're going to have to take a chance. So beside that, it's very clear that, C# is great. What else? Okay, it's amazing. C# is fantastic. Okay, I can see where this is going. All right. C# established, C#. Okay, there we go. So in this talk, I'm also going to show you some stuff that you typically may not find in Total Beginner Resources. And that is the section on the pro tips. If things get a bit too technical and you have questions, feel free to ask them afterwards. We're not going to go too deep. I can't promise I'll be able to answer all your questions to your satisfaction, but I'll try. So first off, let's get into what C# and .NET are. There is some confusion out there around why we say C#, why we say .NET, or combine inside just C#. And this section really aims to clear that up. In a nutshell, C# is a programming language, whereas .NET is a framework that provides you with a lot of native functionality. It wraps a bunch of libraries and the runtime. You can kind of think of .NET as Java's JVM, Java Virtual Machine, plus even more libraries. For example, instead of having to pull in something like Java Spring Boot, it already becomes part of the whole .NET framework. And what you see on the screen now is your typical buzzwordy definition of C#. C# is a strongly typed language. It has cross-platform development, scalable enterprise software. It's kind of on the nose, it's kind of verbose, it's kind of marketing-y, but it is true. The current state of affairs is that it is a strongly typed language. It is cross-platform, and we'll get into that a little bit more when we talk about .NET Core. For now, C# can be run on platforms such as Windows, Linux, macOS, Xbox, iOS, and Android, all with the same code base, very similar to Java. So gone are the days where C# could only be run on Windows. If you want to write a mobile app and just use one code base, you cannot do that with C#. If you want to write a video game that runs on Windows, Linux, macOS, and Xbox, you can also do that. So besides those buzzwords, what are some other things that C# offers at a higher level? Well, with the cross-platform move, C# and .NET have become open source. For the first 15 years or so of the platform and the language, Microsoft was really the only group working on it. But now, every single piece of C# and .NET is open source. You can contribute to it. It's all on GitHub. Microsoft still plays a large part in the future of the platform, but there is a really strong community around C# and .NET. In fact, there's a foundation, a third-party foundation, to foster this community. It's called the .NET Foundation. I would recommend you check them out. They do some great work. Other than open source, C# is also very widely used. You'll encounter C# in a lot of enterprise companies looking to develop these scalable desktop applications or web services. C# can be used if wanted even as a full-stack technology. And lately, they've been making grounds into replacing JavaScript altogether through the new Blazor framework, which makes C# compiled down to WebAssembly. So C# was the 7th most popular language on Stack Overflow in 2019. Now, that may not sound very important or very impressive, really, but it does show that there is a big community online out there. Being able to utilize that community and find answers to any question on C# you may have is priceless. If you have ever worked in a language that is new or it's not widely adopted yet, you'll know that trying to troubleshoot an issue online is incredibly painful if there are no documentations, if there is no established community. And lastly, I've mentioned it before, C# does have really good native libraries through .NET, and I'll touch on that a couple of times throughout this talk. In fact, we're going to touch on it right now. So moving into .NET, what is .NET? Typical explanation is that .NET is a collection of libraries that provide common functionality to host program languages. And that is true. There's a bit more to it, though. This collection of libraries is pretty massive, and it does contain most of the functionality that you need on a day-to-day basis. In fact, I go as far as say that it is a little bit rare to have to do something that .NET does not at least have a basic helper package built in for. Unlike some other languages where you may have 500 third-party dependencies, in .NET you typically may only have a handful, if any. But in order to explore .NET and C# a bit further, we should get a little bit of ground knowledge of the ecosystem. There is an unfortunate part about .NET in that people often do talk about it as if it was just one thing. And I've done this already, and we're only about 9 minutes in. Because .NET for a very long time was just one thing, we need to be careful to make some distinctions here. Initially, .NET started with the .NET framework. This is the desktop-only, Windows-only .NET that's often coupled to C#. About 10 years in, Microsoft did start to experiment with what I like to call .NET spin-offs. And those were things like .NET Micro and .NET Compact. They were targeted at resource-constrained environments like mobile phones and embedded devices. But it wasn't until around 2016, when .NET Core came to the foreground, that Microsoft had a successful spin-off on its hands. .NET Core is what makes the .NET collection of libraries run on platforms such as Xbox, iOS, Android, and Mac with one code base. Now, it is worth pointing out that .NET Core owes a lot to Xamarin, which is a project and a company started in 2011 and is now owned by Microsoft. Xamarin really created the implementations of the underlying .NET tech for those mobile devices. And then the third, perhaps most important flavor of .NET in 2020 is .NET 5. Now, you may be mistaken in thinking that .NET 5 is simply a new iteration of .NET Framework, .NET Framework 4, we go to .NET 5. But no. In fact, .NET 5 combines all currently existing streams of .NET into one unified shell. So we now have .NET Framework, .NET Core, Xamarin, Unity for video games, ML.NET for machine learning, and much, much more in one package. .NET 5 released their second release planned last week, and it is slated for official release fairly soon. But let's consider .NET Framework 4 for a quick minute. Like I said in the previous slide, .NET Framework is what started this all. It is the OG version of .NET. It is the old school way of doing things, but it is still supported and run by a lot of programs out there in production. If you end up working on a desktop application written in C#, the likelihood of it running on .NET Framework 4 or lower is very, very high. And .NET Framework has a couple of really good things going for it. Because of its longevity, there is that massive community around the framework. Help is really easy to find online, and the framework itself is very, very stable. It has some great hooks into some Windows APIs, which make dealing with graphics a little bit easier. And you may have heard of things like WPF, WCF, WinForms, UWP. These are all traditional .NET Framework technologies, and some of them have now crossed over to .NET Core. Somewhat. They're still working on those things, and now with .NET 5, there's another variable in the mix. But let's keep our pace a little bit and hop over to .NET Core. If .NET Framework is the Windows-bound desktop application way of using the .NET ecosystem, .NET Core is the polar opposite. It allows us to run on .NET. It allows us to run .NET on platforms, like I said, like Linux, Mac, iOS, Android. When .NET Core first came to light, the decision was made to put an emphasis on web APIs. As a result, GUI programming with .NET Core is not very strong, but strides are being made there. Where .NET Core really excels is as a backend system for large enterprise cloud applications. And you can think of .NET Core in a similar vein to maybe something like Kotlin, Ruby, and Go in terms of use case. Of course, that's a gross oversimplification, and it would be easy to pick apart the favorite model. It's what I got. And .NET Core brought in a new type of developer into the .NET ecosystem, the non-Windows developer. And the importance of this cannot be overstated. Previously, Java, which we could very well position to be C#'s main rival, as far as we want to promote such a language war, which is not at all probably. Java had a bit of an edge up to C#. Because Java had the JVM compiler targets to instruction sets on many different platforms, you could run Java everywhere. In fact, it was in their installer, and still maybe. Java runs on 2 billion devices. Well, C# didn't. But now, with .NET Core and .NET 5, you can do the same thing. Like with the JVM, any language compatible with the underlying tech, which is the CLI, the Common Language Infrastructure, a standard specification that languages adhere to. All these CLI applied languages can run on .NET and on all these platforms. So if C# is Java, then F#, which is not a language in the .NET ecosystem, maybe something like Scala, they're both aimed at functional programming. They're 2 different languages running on the same engine, but they are cross-compatible. So back to .NET Core. Because .NET Core was a spin-off, we now have 2 main streams of .NET, Framework and Core. Anybody who has ever had to maintain 2 flagship products at the same time will quickly realize what a maintenance and PR nightmare that is. Luckily, the good folks at Microsoft and in the .NET community did cook up something for this. .NET 5. So as mentioned already, .NET 5 is the combination of all things .NET under one big umbrella. You can kind of think of it as a reboot of the .NET platform. Gone are the days where you use .NET Framework for a Windows desktop app or a video game, and .NET Core for a backend service or a mobile app. You want to do any of that? Great. Just use .NET 5. Now, of course, it's not all fun and games with .NET. Like many other programming languages and platforms, C# and .NET have their strengths and weaknesses. Considering that .NET basically runs on a virtual machine runtime, it uses just-in-time compilation, part of its execution story, and it uses a garbage collector. There are certain things that the platform isn't great at. The most obvious weakness of C# and .NET would be interactive graphics, putting aside video games as 3D media. Embedded and low resource development are also a weak point, as is operating system development. Because of the virtual machine, garbage collection, and JIT limitations, you are often better off using something like C or C++ for those use cases. On the other hand, by using C# and .NET, you do get a very mature and scalable platform. It is open source and has that massive community. And that is what makes C# and .NET such an excellent choice for enterprise development. All right. Now that everybody has some basic knowledge around C# and the .NET ecosystem, let's move into a little bit more technical stuff. Most developers have touched object-oriented programming in some way, shape, or form. You may not be very familiar with the ins and outs of stuff like polymorphism, inheritance, encapsulation, what have you, but you've probably used them or seen them used before. And C#, like many popular languages, is easiest to write in when combined with OO concepts. Now, instead of focusing on the basics of what is inheritance, what is insert object or concept, I want to show you two main things: how encapsulation works in C# and how polymorphism works in C#. Encapsulation, the practice of hiding your data so other methods or developers can get their grubby little hands on it. In the words of the immortal MC Hammer, you can't touch this. Putting aside a giant discussion on what design patterns you could use for achieving perfect encapsulation or what it really means, perfect encapsulation, C# provides a couple of ways, a couple of types to encapsulate data. The class, the struct, and now with .NET 5 director. Here we're going to talk about the class and the struct. You're probably very aware of both of them, and we're very quickly going to hit them against each other. But I really want to focus on some ideas around properties and fields and how we can control access to the data they contain. Things like getters, setters, auto properties, read or write only properties will show up. To highlight some differences between a class and a struct, I do want to preface this by saying that, in my opinion, structs are highly underused in the C# world. I have seen very, very few in actual production code, and I think it is because people just forget that they even exist. When you go to instantiate a class or a struct, things do look very, very similar. And depending on your language of choice, the syntax still may look a bit odd, but it's your typical C-style language fare. But surely there's got to be a bit more to it than just this syntax word difference. And yes, the main critique levied sometimes against the class type is that it does add some overhead. And keeping in mind, when I say overhead, we are talking about milliseconds, if even that. But every little bit does add up. Structs, on the other hand, are very, very lightweight. This is both because of the way they are allocated in memory. They're allocated on the stack versus classes on the heap. And because of this. In a class, you typically allow for a lot of staging. In a struct, you typically try to avoid that. typically you don't want to change any state through a struct. It really should be a place where you just put some data, store that data, retrieve it, and then move on. And then to me, the biggest practical difference between classes and structs, it's their behavioral constructor. And this is why I really like structs. So when you add a constructor to a struct, the compiler will force you to assign every field and property in that struct a value, or it will not compile. In a class, you don't have to do this. In a class, you can add a constructor and assign some fields a value, ignore some properties, and the result of that is a possibility that you now have instantiated a type that is not fully initialized. Now, if you do not add any constructors to a class or a struct, the compiler still does generate a default constructor that sets all property values to a default value. You just don't see it is all done on that. To drive this point home that, in my opinion, structs are awesome, I'm going to show you what a struct looks like and a little bit of fun that we can have with it. So, since most people on this call are probably in the UK, and you have much better cookies than the US does, I decided on a struct that models a biscuit type. So, have a quick look at this biscuit type. It's fairly straightforward. There are 3 private fields: name, is_delish, and circuit size. C#'s naming convention states that private fields are prefixed by an underscore and camel case. C# does have some wonky stuff going on with its naming conventions, and we're going to see some of that later on as well. But you'll get used to it. I made the serving size a type of byte, mainly because if you consider a serving size of any cookie to be larger than 255 or so individual units, I have some questions. Also, the more restrictive a type you can get away with, the less memory you're using, and it just makes for a cleaner code. And notice that we do have a constructor here, and this constructor does assign every field a value. We are assigning values to name, is_delish, and serving size. To use this struct, all we have to do is instantiate it. So to instantiate a struct, we just say new struct or new biscuit in this case. So here we create a new biscuit with the name chocolate hobnob. We've determined, sure, these are delicious, so we pass it true, and we'll go with a serving size of 4. Let's not completely pig out. Similarly, if we came up with a biscuit that is not delicious, we can also create an instance for that. For this, I went with fig rolls. I despise fig rolls, so I definitely would say they are not delicious, so I pass and false for that. And because I don't like them, let's just do a serving size of 2. I'm not going to want to eat any more of them. And lastly, if you really want to push the boundaries of the serving size limit, as well as open up a can of worms regarding whether something is a cake or a biscuit, we have Jaffa cakes. Now, because I love Jaffa cakes, to me the correct serving size is 255 cookies, which is very lucky for us. Because if we were to try to pass in a value of 256, we'd have a compiler error on our hands due to the underlying type being a byte. Unlike some other programming languages, I believe JavaScript is one of these, where it will let you fail at runtime in this scenario, but C# will not even let you pass an invalid value for the specific type. So now we have 3 instances of this: Java, fig roll, and Java. But what if we want to access any of its internal fields, like name, is_delish, or serving size? Well, we can't. Right now, they are private members of the Biscuits Struct. And that's the first and probably most obvious example of encapsulation at its simplest. We're just hiding away the data. Nobody can touch it but us. Yet, that doesn't really serve a real-world business logic purpose most of the time. For example, what if we have a requirement? Print out the names and the serving sizes of all the cookies that we consider delicious. We know from instantiating our objects that we print out the name and serving size for chocolate hobnob and Java. To access this information, the nuclear option would be to just make all the internal details public. If we change the name, installation, and serving size fields to have an access modifier public, we should be able to access them elsewhere. Now do note the change in naming convention from private with an underscore and camel casing to a scout casing where every first letter is capitalized for public. And to use this, what if we add our biscuit instances directly into a list of biscuits and then print out the information we want? Here we do a simple ForEach over the list of biscuits, determine whether the biscuit is delicious, and then use what is called string interpolation to directly inject expressions or method calls to a name getter into a string to print all the information out. Is this the best way though? I'd say probably not. Imagine this scenario. Somehow, somebody at the Figwell company got a hold of your source code. They create a class somewhere in the system that changes any instance of biscuit with the name Figwell to be delicious. Now, because the isDelish field is public, this would be possible. And obviously, we don't want to do this. So it's better if we lock down our data a bit more and encapsulate the read and write story of the Biscuits Struct a bit better. What if we could make it so that the isDelish field can be read from anywhere, but can only be written to by logic in the Biscuit constructor? We can use C#'s read-only keyword. When we say a field is read-only, that means we can only explicitly write to it once. A read-only field can only be written to by either inlining the value assignment in the declaration or through a constructor. In effect, this means that we can always read isDelish as it is to public, but we can only write to it once, which is due to this constructor. But what if we want to be able to write something from anywhere in the code, but only be able to read it in its own class construct? Well, for that, we have to switch gears a little bit, make properties out of these fields. The typical way to accomplish something like that is to make your property private and then create a getter and setter method with the appropriate access modifiers. Public, in our case. So in this snippet, I changed the serving size field to private and added two methods, get serving size and set serving size. These methods use what is called the expression syntax in C#, and they're somewhat similar to lambda expressions. This approach works well for when you only have a couple of properties to deal with. But once you have a bunch, your class can get cluttered really quickly with all these getters and these setters. So C# introduced what is arguably a better way. That's auto properties. An auto property is a property that inlines either the getter or the setter, or both of them. As you can see with serving size in this snippet, we can also add access modifiers to the getters and setters. If you don't provide an access modifier, like when serving size is set, it takes the access modifier of its parent, which is public. If serving size was something that was protected or internal or a combination thereof, it would have taken that. Now, if you only want to have a getter or a setter, you can just leave out what you don't want. And finally, we can also provide an implementation buddy to the getter and the setters by adding lambda expressions or buddy methods. So here we do some input validation on the setter of serving size. Now, obviously, assigning a negative value to the byte is going to be a bit of a struggle, but bear with me here. We can simply add any expressions we want as the body of the setter, and this under the hood gets compiled to exactly what we saw before with separate getter and setter methods. So in my opinion, this is a little bit more cleaner. It condenses the code a little bit, and it is probably the most idiomatic and clean way to deal with basic data encapsulation in C#. Now let's turn to polymorphism and generics. Similar to generics in Java and templates in C++, C# allows us to use generics and the list of substitution principle. If it walks, eats, quacks like a duck, it's probably a duck. We can use that to perform polymorphic logic. But to really use polymorphism, we should really quickly look at inheritance and how that is done in C#. I don't want to dive too deeply into it because the topic of inheritance with C# just doesn't have a whole lot to talk about, besides that it doesn't support multiple inheritance of interfaces. And every type in the language ultimately derives from the object type. The thing that is a bit different from other languages is the syntax around inheritance. There are languages out there like Java that make you spell out whether you are extending or implementing something. In C#, it's all done with one operation. So let's take this interface and this class and make a different class that inherits the animal class, the verbs interface. All we have to do is add the colon operator and then the interface and the base class. There's no messing with extends or implements. And that is really all you need to know about inheritance for now. But what is a generic? When we say programming with generics, in practice, this often means a combination of two things. Programming to interfaces, or the highest level type, and using a method or a type that allows for generics. A generic is a type in its most generic form. So often when a type is not specified, we write the T operator. The letter doesn't really matter as long as it's consistent. So how do we put this in practice? Well, we could make a list, which is inherently a generic collection, and make that a generic list based on the Labrador class. So we swap out the T operator for the type that we want to use. And this means that this list can operate on any instance of Labrador, or any derived instance of Labrador. If you had an instance of a class called kittycat that does not extend Labrador, it would not be able to add to this list. The compiler would throw an error. It is often a bit more useful to go somewhat higher than your immediate type classes level. So when we say Labrador, we can also say we want to have a list that can operate on all types extending the animal class or implements the props interface. And in that scenario, Labrador instances can be added to both of these. So why is this useful? And how do we really do polymorphism into this? Now imagine you're implementing the command design pattern. The command design pattern consists of an interface with an execute method and commands that implement that interface. So this allows us to create the right classes and simply call the execute method, not having to worry about any implementation details in those classes. And here we create two classes that implement the command interface. Both classes write to the output console. Now we have command 1 that outputs command 1 and command 2 that outputs command 2. If we were to create a generic queue, a queue is a built-in generic data structure that .NET provides. And we add an instance of both classes that derive a command. We can offcast these to the command type because the queue is a generic collection of type command, and use them as if they were just command types instead of command 1 and command 2. So we can then loop over the command queue and just call execute on all of these. I don't care what they do internally. I just want to call execute and have them do it. So that brings us to the close of the whole polymorphism story. There's a lot more to polymorphism in C#, but this is always a good example, I think, of how to use it in a nutshell. And with that, we're going to go to some pro tips. This is the last section of the presentation. We almost made it. And we've discussed some history, some definitions of C# and .NET and .NET Core, and we looked at encapsulation, inheritance, and polymorphism. Now I want to focus on 2.5 of my favorite pro tips. Now, that being said, what constitutes a pro tip very much depends on what you already know or don't. If you already know these pro tips, then they're probably not pro tips for you. But first off is some fun with LINQ. LINQ stands for Language Integrated Query. And it's a syntax that allows us to deal with collections in an almost functional way. And LINQ is to C# as streams are to Java. They are very similar and they serve a very similar purpose. But the syntax is a bit different. And like with streams in Java, LINQ can look a bit funky at first, but once you are used to it, you find yourself using it quite often. The basis of our exploration of LINQ, and we're going to look at the ForEach and the where methods, is this little code snippet that we saw earlier. There is no LINQ code yet on this. If we zoom in a bit into the second half of the code snippet, we spot the ForEach loop, which in turn prints out all the details about the delicious biscuits. It's this ForEach loop that we're going to replace with a LINQ for each method call. The syntax for LINQ is typically the collection that you want to operate on, followed by the method. The LINQ methods accept a lambda predicate along with an expression. And this expression can be a single statement, or it can be an entire method body wrapped in curly braces. It's whatever you want to do. By replacing the ForEach loop with a LINQ for each method, our code is a little bit more condensed. Depending on your personal opinions, this may be a little bit easier to read. But it was a bit of a trivial change, right? It hasn't changed that much. But once you combine LINQ method calls, once you chain them, you can definitely do some interesting things. Within our ForEach method, we have a method body that prints out the name and the serving size of all the delicious biscuits. We were able to condense that a bit with that ForEach method call. So maybe we can do the same with this conditional check based on the biscuits is delicious product. If we were to use the LINQ Where method, we should be able to say, for this collection, select all the elements where condition X is valid, and condition X would be where the biscuits are delicious. And perhaps the most obvious attempt to implement where and ForEach together would be as you see on this slide. Unfortunately, this doesn't quite work. The where method returns a type of IEnumerable, whereas the ForEach method expects a type of list. Now, these are not compatible. And this incompatibility prohibits us from chaining these two methods together. So until we find a solution for that, the best we can do is to take the resulting IEnumerable type from the where method and just do a regular ForEach method over it, which is what you see here. We do a regular ForEach method over the resulting IEnumerable collection, and that collection only contains the delicious biscuits. So we're good to print out the names and serving sizes of all those elements. Now, I don't know about you, but I am still a bit unhappy about this. I would still like to be able to chain ForEach and where. So perhaps instead of relying on LINQ, we should just roll our own. And that brings us to extension methods. C# allows you to define methods that operate on types directly, rather than live in specific instances of types. For example, in the scenario outlined in the previous couple of slides, we can create an extension method called ForEach that works with all IEnumerable types. And extension methods are static, so they can be called from anywhere. All we have to do is declare a static public method, preferably in a separate extension methods class, that says for type of X, which is an IEnumerable of T, where T stands for biscuits during our code, do this action for all elements in the collection. And the weirdest part of this method signature is probably the this keyword. That is what makes it an extension method. We are constraining this method to be called only on the type immediately following the this keyword. Now, this doesn't mean that you actually explicitly pass in the IEnumerable instance. We only pass in the action. An action is a type that for us now wraps whatever expression or lambda predicate we want. So how would we go about actually using this? Does that look familiar? It's the same code we saw a couple of slides ago when we tried to use the LINQ for each method and the LINQ Where method. Now, back then, the code did not compile because links for each method is incompatible with the given type. But this time around, it does. We are in fact calling our own ForEach extension method now. And extension methods can be a very powerful tool to, well, extend functionality types. And that brings me to the close of this talk. I do have some suggested readings. I highly suggest you check these out if you're interested in learning more about either C# or clean code in general. And then feel free to connect with me on LinkedIn. Don't forget to enter the book raffle, and there's the 20% off Code Like a Pro C# coupon. That's what I got. Thank you, guys.